Okay, now we can set up the scene for the RBD simulation. Let's start creating the trajectory for the bullet. Just down a couple of points. And the third one to create the polygon. Let's call the first one start point, end point, and trajectory. Trajectory will be polygon by group. Okay. Start point, we will change it later, but for now, let's say 5. And we have our trajectory. Okay. Now let's create the bullet. Courvoisier. And something like this. I'm not very good at modeling in general. Okay, resample. Okay. And revolve around the z-axis. Let's say 40 divisions. Okay. And a polyfill maybe. And this is now our bullet geo. Okay, now in order for the bullet to stay on the trajectory, we can use a curve node here. Curve with the option of extract points, which is this one. Yes, okay. And now we can say copy to points the bullet over this point. And we should have, okay. Now maybe we can resize the bullet a little bit. Polyfill. Transform. Let's say 0.15. Seems okay now. And before copy, maybe we can pack the geometry and say name bullet and assemble. Do not create name. And now we should have a single point named bullet. Okay. This is our bullet animation. Okay. Before continue, let me do something with the box because it's quite important. Right now we are using an impact point manually created here. Instead, I would like to use the intersection with the trajectory. So let me put down the tail angle. We can use the box as second input and a object merge trajectory as a third input. And we can say something like vector start pose is equal to point input the third one 0 and the endpoint is the 1. And pose, the direction is end pose minus start pose. And we can now need to create some variables for the intersect function. Intersect position and float u and v, which we are not gonna use. Int result is equal to intersect geometry origin direction. Okay, geometry is 1, origin is start position, direction dir, intersect pose u and v. You should be correct. Okay, if result is less than 0, we can raise a warning. There is no intersection between the box and the trajectory. Otherwise, we can create the point. Intersect pose. Intersect pose. Okay. Let me check. Perfect. Okay, now we can apply a polybevel to the box. Zero, 0, 2. Yes. Even 25. 4 divisions. Okay. This one is impact point. Okay, for the glass fractures, first of all, the level should be smaller. Let's say 500 Voronoi points. Radial lines, we can increase a little bit the distribution. Okay, maybe a different seed. Okay. And now we can just duplicate this one. Will be 2 meters along the Z. Okay. And other 2 meters. Just to visualize all together Okay. Let me change the parameters here. A different seed. Maybe okay. Now, before the dot network, let me put down a couple of null. This will be box to collider. And box 3 collider. I will explain in a second. We should have everything in place now to create a dot network. Okay, let's connect the glass to the first input. Box 1 sim. And by the way, we still need to animate the bullet. So let me fix the trajectory. Okay. We are going to use 240 frames at 24 FPS. So the curve goes from 0 to 1. Linear. Let me check the bullet. Okay. So, rigid body solver. RBD path object for the glass. And another one for the bullet. This one is first contact geometry, and the bullet is bullet anim, which is animated static objects. And then the collider, which is a static object. Box 2 collider. Okay. Seems fine. maybe less bounce here. Okay. I usually put down also a pop drag and a pop drag spin as a post solver, but just to ensure a more stable behavior. But in this case, I would say that it's already fine. Okay. Okay, now the simulation start at, let me see, let's say 18. Box 1, simulation, start frame 18. And then we can just use a DOP import. We only need the RBD glass. Okay. Then we can unpack. Impact zone and nothing else. And now we are ready to work on the cracks.